Hello students, Ms. Slyman here, and I'm going to talk to you some more about this Lesson 2 practice from Unit 8 about finding equations for exponential functions if we have the graph. So remember, our exponential functions have a general equation of y equals k times a to the x plus c. And in this general equation, my c value gives me my asymptote. So remember, all exponential graphs have a horizontal asymptote at y equals c. So in this case, looking at this one, my asymptote is the x-axis. The equation of this line is y equals 0 because I go through the y value of 0. That in turn tells me that my c value is 0. Well, now, if we think about the x-intercept, remember that x-intercepts happen, y-intercepts happen when x is equal to 0. So if I come back to my original function, that's going to give me k times a to the 0 plus c. Well, a to the 0, of course, is just 1. So my y-intercept is going to be k plus c. I'm going to drag this over a little bit so that we can label this as the y-intercept. So if we have previously found our c value and we know the y-intercept, then we can find the k value. So the k value is going to be the y-intercept minus c. So c is my asymptote, y equals c. My k value is going to be the y-intercept minus c. To find the a value, we're going to plug in another point. So let's try all this with an example down here. So in this example, it seems to me that y equals 1 is my asymptote. So coming over here, it would be somewhere around there. So y equals 1 is the asymptote. Therefore, my c value is 1. I see that I have a y-intercept over here at 2. So I've got y equals k times a to the x plus c. Plugging in what I know, 2 equals k times a to the 0 plus 1, because we've determined that c is 1. A to the 0, well, that's just like saying 1. So k is equal to 2 minus 1. So that's also going to be 1. Now I'm going to pick a third point. The best point to pick is when x equals 1. That's because if x equals 1, I just get a, because a to the first power is just a. So I see this point 1, 6, and that's going to let me find my a value. So 6 equals k times a to the first plus 1. This is just going to be a, so subtract 1 to the other side, and I'm going to get a equals 5. That tells me that this equation, y equals, I can write 1 for the k, but I don't have to, so 5 to the x plus 1. Let's try one more. All right, this one, the easiest part about this one is looking at my asymptote. That looks like it's 0. So my c value is 0. I see that we go through the point 0, negative 1. So negative 1 equals k times a to the 0. Again, that's just 1. Plus 0, I don't even need to write that. That is also just 0, so k must be negative 1. And now find my a value. I see that I go through the point 1, negative 4. So negative 4 equals negative 1 times a to the 1 plus 0. I'm not even going to write it. Divide both sides by negative 1, and I get that a is equal to 4. So let's test this one out. So if I come over here, I can say that my k value was -1. My a value, it looked like, was 4. And there's my picture, and it seems to match exactly. Notice I've made the same x and y axis so that I can really look at my picture and see if it's the same. And that looks like it checks.